Hey, what's up everybody? I'm going to run you through an example of the four-step process associated with the t-interval for mu1 minus mu2. So estimating the difference between two population means. All right, so here's the example. Students rated on a 7-point scale whether they thought animal research is wrong, a 7 being very wrong. The info from the random samples are shown for males and females below. So we have our summary statistics for females and then for males. And then it says estimate the difference between the population mean ratings using a 95% confidence interval. All right, so we are going to be estimating the difference between two population means. So we have information about the sample means, but we don't know what the population means are. So what we're doing is trying to figure out about how different are the views of females and males about this topic. We know that we're going to be using a t-interval here because we are given the sample standard deviations, so we don't know the population standard deviations. If this were sigma instead of s, we would be doing a z-interval, but we are using a t-interval here. So, okay, so let's get started with the four-step process. So I'm going to start with step 1, where I am going to define my two parameters, so mu1 and mu2. All right, so mu1 is going to be the true average animal research rating for females. So I picked the female population to be population 1 because this X bar value here was larger. What that will do is give me a difference, a positive difference between my two sample means. Population 2 is going to be mu2. This is going to be my true average animal research rating for males. Okay, so now that I have those two populations established, then I can properly notate the sample statistics for, I was provided up there. So the 140 is going to be N1. The 100 is N2. X bar 1 is the 5.353, and the X bar 2 is 3.882. That will give me a difference. So if I were to subtract those two differences, that would give me a difference of 1.471. Okay, so that's what it was for these two samples. What I'm going to be doing is estimating, well, what will that be for the two populations? And then again, I'm going to be using my two sample standard deviations, S1 and S2. Okay, and then again, I'm using 95% confidence, which I'll come back to in a minute. All right, so on to step 2. Step 2 is my conditions. So again, we always want random samples. So in this problem, we were told that the samples were random. Okay, so let's note that. So random samples. Check. Our next one is we need normal sampling distributions. Remember, we can show that just by looking at the sample sizes. My two sample sizes of 140 and 100 are sufficiently large, that being greater than 30. So I'm going to check that. N2 is 100, also greater than 30. And then we also want to check our independence condition. So basically, are these two samples of 140 and 100, is it reasonable to assume that they are less than 10% of the population size. So if we were to multiply these both by 10, we'd get 1,400 and 1,000. Certainly the populations would be much larger than that. So that third condition is also met. So I'll say it is reasonable to assume the samples are less than 10% of their populations. Okay, so now I'm going to name my procedure. So I'll say the conditions for a tInterval for mu1 minus mu2 are met. All right, so that's step 2. So now we're on to step 3, where we actually do the interval. So I'm just going to write down the whole formula for you, and then we'll put it all together. So it's the difference in your sample means plus or minus a critical t-value times the standard error, which is s1 squared over n1 plus s2 squared over n2, and then square rooted. All right, so let's start putting in some of these numbers. So I already know the difference between my two sample means. That's what I calculated up here. That's this number here. Okay, so that's going to be 1.471 plus or minus t. Now, t I haven't calculated yet. So the t that's going to go here comes from the inverse t function on the TI calculator. What you need to put into inverse t is the tail probability of the confidence level. So the confidence level is 95%, so the tail probability would be 2.5%. So I would put that in as 0.025. And then the second argument is the degrees of freedom. So there's two different ways of calculating the degrees of freedom. The one that I usually just use is kind of the more conservative approach. You just use the smaller of the two degrees of freedom, because we had two samples here, 140 and 100. So I'm going to use the smaller DF value, which would be 99. So that's going to go here. So I'm going to put that into my calculator, and that's going to output a t-value of 1.984. I'll show you another way in a minute here where you can, the TI calculator will give you another calculation for t, but this is the one I'm going to use right now. And then I'm going to go ahead and put in the rest of my information. So s1 squared over n1 140, and then plus 1.728 squared over 100. All right, so if I do this, I'm going to put that whole margin of error. So remember, the margin of error is all of this. I'm going to put all of that into my calculator, and I end up with a margin of error of 0.441. So then my interval will be 1.030, comma 1.912. So a difference between roughly 1 to 2 points for the animal research rating was what you would estimate to be that difference between females and males. All right, so I'm going to also show you how to do this step 3 on the TI calculator. So I'm going to flip over to that and hit stat. I'm going to go over the test function, and I'm going to go down to tsamp tInterval, tsamp tInt. So this one here. And it's going to first ask you for input, so data or stats. Well, I was given statistics in this problem. If I were given 2 lists of data, I could leave it on data, but I'm going to move it over to stats. And I have to type in my numbers. So that's x1, s1 is 1.656, n1 was the 140, x bar 2, 3.882, S2 1.728, N2 is 100. Confidence level 95%, so 0.95. Pooled, just always keep that as no, and then go ahead and hit calculate. So you can see here our interval is just about the same as what we calculated. The DF calculation is much different, so it was 207.8, so they use a big formula in the calculator to get this more accurate degree of freedom estimation. But you notice that just by me using 99 didn't really change my answer that much. So that's the 2samp tInt calculator function. All right, so if I head back to Notability here, so again, that's my interval. So now my last step is I'm going to interpret that. So step 4, so the interpretation, I'm going to say I am 95% confident the interval 1.030, comma 1.912 captures the difference in the true average animal research rating for females and males. So that would be my interpretation. So that's step 4 of that 4-step process. All right, so that is the t-interval for mu1 minus mu2. Thanks for watching.